I'm out today. But we gotta learn. So, here's the deal. I know how excited you are. I don't know why I always play with my hair. This big mouth filter is my favorite. So, here's the deal. You have a video. This video is like 25 minutes long, but it's me walking you through all these things. You need to copy the notes, take the notes. You got this. I just needed to put it out there. Don't act crazy. Don't be that person. Do not be that person. Be the person that sets the standard. We're building this culture. We're setting the standard. We're going to have a glorious math period. Sub, where are you at, sub? Where's our substitute? Thank you for taking my class. I don't know where you're at. I can't look at you. Thank you for taking my class. These kids are fantastic. They're wonderful.
Okay, everybody. Sorry I had to be out today, but we're going to do area of composite figures. I wanted to do this one as a YouTube with Lubelski so that we can kind of take our time and go slow through this. This is where everything we've learned about parallelograms and triangles and the formulas for area come into play, because today we're going to do area of composite figures. And composite figures means that it's just simple shapes like circles and squares and rectangles and triangles put together to conform this composite or this complex shape that looks different. And so we don't have area formulas for that. So today we're going to be using the two formulas that we have learned. We've learned area equals base times height for parallelograms. And we've learned area equals base times height divided by 2 for triangles. And so those are the two shapes that we're focusing on this. So in this first section, it says, in art class, Mrs. Price is discussing how figures can be decomposed into different shapes. She projects the images below on the screen. So we're going to discuss and label the different ways you could decompose these figures into familiar shapes or our basic shapes. So when I'm looking at this first one right here, this first one, I see two simple cuts that I can make. I have this and this. Okay, so this is the first one. I'm going to go through all three of these, and then we're going to use a different color pen to see how there's other ways we can do it. In this next one, in that middle shape, the one that we want to cut out, that middle shape can be decomposed into a triangle and it looks like a square. Depending on the measurements, it could be a square or a rectangle, but we do know it's a parallelogram of some kind, so we'll be able to use our base times height. The last one, this one can be done in a lot of different ways, but first I would cut this bottom rectangle, and then here I would cut this triangle and rectangle there. Okay, I'm going to use a different color pen. So feel free to grab a red pen from those center baskets, but just make sure that those get zipped back up. I've had a lot of floating markers and calculators not make it back into our bag, so always be mindful of our materials. But you can grab a red marker for this, and we could have made cuts in this first one here and here. That would have created, again, 3 rectangles, but 3 different rectangles. It all depends on what labels you have and what sides are labeled, because you'll need to know that information. For this one right here, the second one, the only way that we can cut that is where we did, okay? There's no other triangles. We could, if we had certain measurements and stuff, we wouldn't want to make more work for us, but we could cut on the diagonal of the parallelogram to have 2 triangles. But again, why would we want to do that if it's as easy as just making 1 triangle and 1 rectangle? On the last one, however, we could have cut here down this way, and then we could have made the triangle here. So just a slightly different cut. You still end up with 2 rectangles and a triangle. But ultimately, whichever way you visualize it and whatever measurements you're given, that's what you're going to want to focus on. Okay, so let's take a look at these little notes we've got. We've got a composite figure. Composite figure is made up of 2 or more shapes. So underline 2 or more, because that's when we have to use multiple formulas. It might be the same formula repeated if we have the same basic shape multiple times, or it could be 2 different formulas like a triangle and a parallelogram. We can find the area of a composite figure by decomposing the figure into familiar shapes. So decomposing just means to break it apart. So break apart. Then at the end, we're going to have to add and possibly subtract both, or maybe one or the other, in order to find the area of each shape. So let's try our first one. Decompose the figures below, then use the graphic organizer to find the area of each shape. So the first thing we're going to do is we're going to take that red marker and we're going to decompose this. It looks like a house, but I don't have a formula for a house. My graphic organizer over here tells me that I'm going to end up with two shapes. So just by looking at this, I see that I could cut this and cut the roof off the house in my mind. Okay, so visualizing this is something you know can be helpful. So I'm going to cut the roof off the house, and that creates a triangle and a rectangle. And so let's see what numbers we can label. So what did this just cut apart? Well, I know that it's 8 feet on this side here. And then my base is going to be 9 feet. I love that they provided this for us. And up here we can draw our 90 degree angle, because we can see that that's going straight up and down into the side of the base that we just created. So there's our 90-degree angle there. The tricky part here is knowing that opposite sides of a rectangle are the same. So the base of my triangle is going to be that 9 feet. Now the height is the trickiest part. The base all the way up to the vertex of that triangle is 12 feet. The base or the height of our parallelogram over here is 8 feet. So we're going to have to subtract 12 minus 8 to find my 4 is my height of that triangle. And so that's the first thing I always want to do is label all the little pieces. I need to find all the heights and the bases and the sides of all these simple shapes. So let's fill this in. So the shape 1, we're going to say shape 1. I'm going to circle that so I know it's the name. It's a triangle. And the formula for a triangle is half base times height, or we've been writing it as base times height divided by 2. So those are the same things. I apologize if you hear some bells in the background. My dogs are acting kind of goofy while I'm making my video. All right, plug-in values. So let's identify those plug-in values. The base of my triangle is that 9 feet, and the height of my triangle is the 4 feet that we found. So let's plug that in. I want to do my base times height, which is 9 is my base, times my height of 4, and then we're going to divide all of that by 2. So with your calculators, we're going to type that in, 9 times 4 divided by 2. I'll give you a second to do that. And we should have come up with 18, and we have feet as my unit, so feet squared. Okay, shape number 2, our second shape is that rectangle. So we're going to do rectangle as our second shape. And our formula for a rectangle is that base times the height. And this one was a little bit easier. Our base was given to us, that's 9, and our height was 8. So base times height would be 9 times 8. This is a multiplication chart one. You can grab your multiplication chart. If your calculator is accessible, you can type it in there. 9 times 8 is 72, and then our units are feet squared. Now, when we're looking at this, this is a composite figure that is being combined. So we have a triangle and a rectangle being combined with one another, which means that I actually have to add these two together. So let's set that up. 72 plus 18. 2 plus 8 is 10. 1 plus 7 is 8, plus the extra 1 is 9. So 90 total feet squared is the answer to our first figure. Okay, On to our next one. So this cool looking shape, I can already see the outline. So if you draw your eyes to here, we can already see the makings of a triangle. So we're gonna use that as our where to cut. So I'm gonna go ahead and cut this over here. And that creates my big rectangle on the bottom, which already has my base listed and it has the height of that listed. My triangle, on the other hand, is a little bit more complicated. The height going up and down where we cut it, that's a 90-degree angle. So my height is that 4 meters, but that 5 is not my base. My base is actually this piece here. So right here to here, which means it's only part of the 15. And so that shorter piece right there is actually the 15, which is the whole bottom. Subtract the 5. And our actual base for the triangle is 10 meters. So this is going to be my first one. I'm going to do that as my first shape. So again, we have a triangle. And we're going to do the base times height divided by 2. The base of my triangle is 10 meters. The height is 4. And then once I multiply those, I'm going to cut those in half because we're talking about a triangle. So 10 times 4 is 40. And half of 40 is 20. And it's meters squared. The second shape that I've got is that rectangle on the bottom. So shape 2 is my rectangle. Again, we're going to use base times height for a rectangle because it's a parallelogram. And we've already got our base is 15 and our height is 6. So grab those calculators and you're going to type 15 times 6. We should have gotten 90 meters squared. And now we have to add those two numbers together because, again, composite figure is similar or familiar shapes put together to create a complex shape. So 0 plus 0, 9 plus 2 is 11. 110 meters squared is my total area after I combine those two together. Just a little break here. This is what I get to stare at when I make your videos and being watched, and it's creepy. Those two are just fighting. Okay, math break over. Okay, let's flip over to the back. Okay, so for our first one, this one can do a couple of different ways. It's a rectangle inscribed in a trapezoid, so we're removing that rectangle out of the middle. Now there is actually a formula for trapezoids, but we're going to use our knowledge of triangles and parallelograms to do this instead. So inside we've got this shape right here. The rectangle is one of our easier ones because we already know that we can label the base and then it's pointing the arrow to the height. So this is my height right there of that parallelogram. So in a similar fashion, we're going to do shape 1. Okay, so shape number 1 is our parallelogram. So that's going to be base times height. And that's going to be 7 is our base, 5 is our height, for a total of 35 inches squared. For our second shape, shape number 2, our second shape is also a parallelogram because I can cut off both triangles on the two ends. And the triangle height is the same as that inside parallelogram height. So 8 is the height of the parallelogram, the big one. And our base is going to be 10, not the 15. The 15 is referring to this big long line. We only want the shorter 10-inch one. So base times height again for our shape 2 is going to be 10 inches times 8 inches, which is 50, not 50, 80 inches squared. Now, for the two triangles on the end, that's where things get a little bit trickier because we actually have to look at putting those two triangles together. So if I slide those two triangles together, they create one big triangle like this. If I slide them back to back, and it's got my 8-inch height, and then these two pieces is gonna be the 15, take away the 10, which leaves me with a base of 5 inches. So this piece right here, I'm gonna highlight this right here, 5 inches, or these two pieces right here combined are 5 inches. So that gives us the base of 5. So for our shape number 3, so we're getting a little bit harder here, is gonna be base times the height divided by 2. So our base we discovered is 5 with a height of 8, and then we're gonna divide that all by 2. 5 times 8 is 40. When we cut that in half, we get 20 inches squared. So here's where we have to do the addition and subtraction. So this can be a little bit tricky. Our shape 2 and our shape 3, so these two were combined into shape 3. Shape 2 and 3 are the gray shaded area. So we can actually just combine those together to get the entire trapezoid. So that's going to be 80 plus 20 is 100 inches squared. But we're still not done because we've got that white piece in the center that's being cut out of the trapezoid. So we're going to actually subtract that 35 inches squared from the total because we're cutting that out. We're removing that then. That's subtraction. So borrow from my 100. Again, you can use your calculator for this. Borrow from that 10. 10 take away 5 is 5. 9 minus 3 is 6. So our answer for this one is 65 inches squared is our total gray area after we subtract that center rectangle. Okay, let's take a look at question number 2. So, a patio is being landscaped with trees and shrubs. How many square feet of landscaping will be around the patio? So this is a situation where we've got this landscape area. So they're talking about actually the white space. So we want to find that. And this is actually pretty cool because it looks like it's 8 by 14, 8 by 14, and then this is 3 foot, 3 foot, and then the arrows are both pointing to 3 feet. So we actually only need to figure out one of these landscape areas because there's 2 of them. So once we figure out the one section of landscape, we just have to double it. So we're going to cut this landscape down, and that's going to leave us with a base of 3 feet and a height of 8 feet. And when we look over here, the base of the entire thing was 14, but we actually have to subtract that 3 so that we have this as 11 feet. So we're subtracting 14, take away 3 leaves me with 11 feet for the base of the second rectangle, and they gave us the height of 3 for the second rectangle. So rectangle 1, rectangle 2, let's do the math on that. So shape 1, we need to do base times height, which in this case is 3 times 8. 3 times 8 is 24, and these are feet squared. Shape number 2, we also need to use base times height because it's a parallelogram. And this has a base of 11 and a height of 3. So that's going to total up to 33 feet squared. Now, because it's a complex figure, it's a composite shape, we need to add these 2 together. So to get my total, 4 plus 3 is 7, 2 plus 3 is 5 feet squared for one landscape. Okay, so that one landscape is 57 feet squared. And we already identified that they are exactly the same on both sides of that lattice, that patio area. So we're going to double this. We're going to times this by 2. So 2 times 7 is 14. 2 times 5 is 10 plus the 1 is 11. And that's 114 feet squared as my answer. Okay, let's move on. All right, this one has some decimals in it, so we're going to use our calculator to make our computing go a little bit faster. A composite figure is created using a rectangle and a triangle. What is the area of the figure? So they told us the two that we're looking for, a rectangle and a triangle. And then we want to find what is the area, which means we'll have to use our area formulas. So I can see that the triangle is formed on top of this, just like the house one we did on the first side of this page. And then when I cut that, I see that the base is clearly 12.4 centimeters, and I can look across and put that as the base of the triangle as well. So 4.4 centimeters on the base of the rectangle and the triangle. The height is given to us right there with 7 centimeters, but the height of the triangle is more complicated because we actually have to draw that height from the base to the opposite vertice. And then we have to take the total height of the figure of 10 centimeters and subtract that 7 centimeters. So 10 take away 7 is 3 centimeters. So that means that the height of this triangle is 3 centimeters. So I'm going to make my triangle my first one, and my shape 2 is the rectangle. So shape 1, I need to use base times height divided by 2 as my formula because it's a triangle. So we're going to do 12.4 times 3, and then we're going to divide all of that by 2. So I'm going to actually do that in the calculator. So I'm going to do 12.3 times 3. Oh no, 12.4. Man, I'm really doing a good job of typing this. 12.4 times 3 equals, and then we're going to divide it by 2. So 18.6. 18 and 6/10 centimeters squared is that triangle. And then our base is our rectangle, so we're going to use base times height for the rectangle, and that's 12.4 is the base again, times 7. So again, back to our calculators, 12.4 times 7, 86.8. Because there are two shapes and they're being combined together to make a more complex shape, we're going to go ahead and add those up. So I can actually do that with the calculator, or let's just practice doing it longhand. So 6 plus 8 is 14. So I'm going to carry that 10, drop my 4. Decimal goes straight down into an addition problem with decimals. 8 plus 6, again, is 14, plus the 1 is 15, so carry the 1, drop the 5. 8 plus 1 is 9, plus another 1 is 10. So 105 and 4/10 centimeters squared is the total area of that complex figure. And number 4. All right. This one is pretty cool because there's many ways that you could do this. Some of you might see it in a different way, but what we're going to do is we are actually going to we're going to imagine sliding this here to create two rectangles. Now it's hard to envision, so I'm going to sketch this out. When we do that, this is actually going to create two sides of our rectangle. The first one being the gray shaded side, and then the other side is going to be our white side. And so if we look at this, wrong one. This 9 meters by 9 meters, we're going to find the area of the entire rectangle and then just cut it in half because half of it's gray and half of it's white. So I'm going to do the base times height, which is 9 times 9. 9 times 9 is 81 meters squared. And we're going to divide that by 2. So we're going to cut that in half. Divide this whole thing by 2 because that's going to give us half of that rectangle. So let's pop into our calculator. 81 divided by 2, 40 and a half. So 40.5 meters squared. Okay, the last one, we're going to cut this one because this has to do with trapezoids and it's got a bunch of fractions and decimals in it, so we're going to skip that one. But summarizing today's lesson, hopefully we can take away that composite figures can be cut into familiar, basic shapes to find area using formulas. May want to pause the video to get that all written down. All right, now we're going to move on to what's labeled as the homework. It's actually just practice. You don't have to take this home. This is all going to go right into your binder. And we're going to do area of composite figures, and this is our practice page. Now, I am going to cut some of these, so don't rush ahead, because we are going to change some numbers. We're going to cut some of the fractions out, and we're going to work on just a few of these for time's sake. So the first one is a neat one because it kind of looks like a checkered board. It's a 2 foot by 2 foot square is divided into smaller squares and portions are shaded. What is the area of the shaded portion? So this one's kind of cool because we know that this side is 2 feet and this side is 2 feet. And there's a couple of different ways that we can do this. So we can find the area of the entire figure. So we could do the 2 by 2 foot and find the area of the whole thing. But then we would have to cut it up into sections and figure out how many of them are shaded. We could also divide up to find what is the base and the height of just these 2 pieces using 2 feet and dividing it into sections. But I think I like the idea of us doing the dividing it up and then finding the base and the height of just one square. And so when I look at this 2 foot section right here is cut into 1, 2, 3, 4 pieces. So we're going to actually do 2 divided by 4. When I write that as a fraction, it's actually 2 divided by 4 simplifies to a half. So that means that this is 0.5 feet. And because they're cut into squares, we know it's 0.5 feet by 0.5 feet. So now I've got a base and a height for one shaded and square. We're going to do base times height is 0.5 times 0.5. So 0.5 times 0.5, and that gives us 0.25 feet squared for one shaded in square. So 0.25 feet squared is 1 square. But let's see how many of them we have. 1, 2, 3, 4, 5, 6 shaded squares. So we're going to actually multiply the area of 1 times the 6 of them that we have. So let's go back and we're going to multiply that 0.25 times 6, which is 1.5. So the amount of shaded area in this is 1.5 feet squared. Okay, number 2, a garden is sodded in the shaded portion below, which means it just has some grass laid over the top of it to take root. It says how many square feet? Ooh, in unintentional zoom in. How many square feet were covered with sod. So we're looking for this gray area in here. And so when I'm looking at this, we're going to actually convert this. So 9 1/4 is the same as 9.25. So that'll help us typing it in the calculator as we do this. We've got these lines right here that we have to recognize. Those are similarity lines, and those lines are telling me that this is a 6 foot by 6 foot right triangle. Okay, it's in the corner right here. And so that's going to be my height and my base of my triangle, and the similarity lines over here imply that it's the exact same triangle. So thinking about that, we can remind ourselves that two identical triangles come together to create a parallelogram, in this case a 6 by 6 foot parallelogram. And so what I want to do is I actually want to find the entire area of the big rectangle and then subtract the area of that square that can be composed from those two triangles. So we're going to start by figuring out the shape 1 is, our shape 1 is going to be the big rectangle with a base of 20 and a height of 9 25 hundredths. So let's do that. Shape 1 is base times height, which is 20 times 9.25. So let's do that. 20 times 9.25, 185. And again, we're in feet squared. Our shape 2 is going to be that square that we made, and that's also going to be base times height. So we're going to do 6 times 6. That's a multiplication fact. 6 times 6 is 36. And because we are cutting off those two corners that create that square, we're going to subtract these two numbers. So let's go ahead and do that longhand. 185 minus 36. This is going to involve some borrowing and carrying. I cannot do 5 minus 6, so we're going to borrow from the tens. 15 minus 6 is 9. 7 minus 3 is 4, and 1 minus nothing is 1. So 149 feet squared is what has been covered with sod. Okay, for time's sake, we're going to go through the last part kind of quickly. It's using the composite figures below to mark each statement as true or false. We're gonna mark it as true or false, but I'm gonna just talk through the justification of it and mark up the figures to show you why it is true or false. So the first question says, let's go ahead. I want to get a highlighter here. So the first question says the area of the figure A can be found by finding the area of a trapezoid. So looking up here at figure A is not a trapezoid. So this is a false statement. Okay. So this is not a trapezoid. A trapezoid has two parallel lines on top and bottom, and then it has two other sides that are not parallel. So it's a type of quadrilateral, and in this case, there's actually 5 sides. So this is not a trapezoid, so we can't just use a trapezoid figure, but it can be cut into a triangle and two rectangles. So we can cut it into one rectangle here, and then we can cut it into a triangle, and that looks like a square, but probably, actually it is a square. I did it. So yeah, it is a square, but two types of rectangles. Okay. Question letter B, the area of figure B can be found by decomposing the figure into a rectangle and a trapezoid. So if I look at this, a rectangle and a trapezoid, if I cut it there, this is the trapezoid and this is the rectangle. So that is a true statement. Letter C says figure B has a total area of 75 inches squared. So this would actually require us to do A and B. I am actually not going to have us do that because of time's sake. We're already probably at the 35-minute mark in this video, so we're going to stop there. I do not expect you to find the area of these two right now, But if you think that you can and you want to do that as an extension at some point, feel free to do that. But this is not part of what will be graded when I collect these papers when I get back and do a spot check on them. So as long as you have this entire page filled out with questions 1, 2, and then letters A, B, and C or A and B for our true and false, you'll get full credit for this. The video is posted on Google Classroom.